Okay, today we're going to look at, we're doing the first part of solving polynomial function equations. So we've looked a lot about graphs, and now we just actually want to get to that goal of being able to solve them. So finding where it crosses the x-axis. And we're going to review some factoring first. So this is Unit 4, Goal 5 that we're going to do, and this will be Part 1. So today we'll just work on factoring polynomials, and then tomorrow we'll look at actually solving them out. So here's a couple of factoring that we need to remember. So these are with cubic functions. So if I have two things cubed, so this would be a binomial, so two terms, but each term is a cube, as a perfect cube, then I can factor it out to here. And if they are perfect cubes and they're subtracted, then I can factor to here. So those will be some things we'll want to keep in mind as we are looking at factoring. Reviewing factoring. So if I look at this is something cubed, but this is not a perfect cube. So there's nothing times itself 3 times. That would give me 420 squared, but not 20 cubed. So this would be a prime. We can't use factoring. That doesn't mean it doesn't have an answer. So it's not a no solution. It's just prime. I can't factor it. So here we're going to look at looking through some examples of factoring again. So since I have two terms, those aren't perfect cubes, perfect squares. So let's take out our greatest common factor. So I have 24 x to the 5th plus 3 x squared y cubed. So I notice I can divide both of the numbers by 3, and I can take out up to an x squared, because this one has an x squared, this has 5x multiplied. So I'm going to take out the greatest common factor would be 3x squared. So that's like I'm dividing each term by 3x squared. So when I divide this by 3x squared, I get 8. Take out, subtract my powers, and I get x to the 3rd. So I have 8x to the 3rd. And here, when I divide 3 by 3, I get 1. Take out my x squared, or divide by my x squared. 2 minus 2 is 0. And I'm left with just the y cubed. Now, when I'm looking at this, these are both cube terms. So I can go back to that formula. When I have two things that are cubed that are added, that equals a plus b, a squared minus ab plus b squared. Make sure I get that right. Yes. So here we have two cubes. So this would be the cube root of this would be 2x plus y. So this is my a and this is my b. So then I need a squared, which would be 2x squared. So 4x squared, and I square this, plus minus a times b. So I'm going to multiply these two terms. So 2xy plus b squared. And then I have my, 3x squared still outside. So this factors into these two terms, and that is as far as that we're going to factor those. So here are just some techniques. When any number of terms, we want to first factor out for greatest common factor. If I have two terms, I'm looking for difference of 2 squared, sum of 2 cubed, or difference of 2 cubes, and these are our formulas. If I have 3 terms, I'm looking for perfect trinomials, or just that I can factor out any of those parts. And this would be like quadratics, and we could use all of that. Would be an example. And if I have 4 more, I want to factor by grouping. So here I have 4 terms, so I'm going to factor by grouping. So factoring by grouping again, we look at the first two terms. And what's my greatest common factor out of those? And that would be an x squared. So when I divide this by an x squared, I get x plus 5. And then I look at these two terms, and the greatest common factor is negative 2. And I get x plus 5. Now notice I have two terms, but each term has an x plus 5. So if I factor out an x plus 5, I'm left with x squared minus 2. Now I'm looking at this to make sure I can't factor any more, and I see there's two terms, so I'm looking at either a difference of two things squared or a difference of cubes, and either of those works, so that is as far as I can go on that one. So we want to go as far as we can, so keep checking to see if I can't go any further. So again, 4 terms, want to use the factor by grouping method. You can rearrange these and you should still get the same thing if you factor out the greatest common factor. So looking at these first two terms, greatest thing I can take out is a, and I get a plus 3y. Looking at these last three terms, I can take out a 2 and a y squared, which gives me a plus 3y. Then I factor out a plus 3y from these two terms, and I get a plus 2y squared. Want to check, make sure that's not two cubed terms, and it's not, and it's not a difference, so it can't be